Okay, thank you all so much for joining us for another CS Skills Exchange session. I did post the notes document in the chat, but we had a few folks join us after that, so I'll repost that document again in the chat. It's also part of the meeting invite. One ask that I have before we get into today's topic is that the Q3 session is live. We are looking for a few slots there to still fill. We have some AM and PM sessions. So if you happen to have a session or a topic that you'd like to cover, please take a look at that issue and let me know what date you will be available. And then we'll pass it off to Taylor to cover today's topic. We'll be talking about data sciences, and there's some key components around that Taylor's going to talk us through. So take it away.
Awesome, thanks. Hi, everyone. My name is Taylor McCaslin. I'm a principal product manager for our ModelOps section. So today I want to talk about an intro to data science. So basically what I want to do is first start with a couple of the use cases that data scientists have with GitLab, and then talk about how you can use various features of GitLab to accomplish a lot of the use cases for data scientists. So I'm going to start initially with a presentation, just kind of give you a foundation of some of the problems and use cases for data scientists, and then I'm going to jump into a demo within a project. The project is something that you can fork and play around with. My goal here today really is to give you a taste of how to use GitLab in a very particular way that data scientists work. So let's dive in. First, just a reminder, everything here is for informational purposes. Everything we're going to talk about is subject to change. I'll talk a little bit about some roadmap items as well, so know that those could shift in timelines. So I want to start first by defining some of the components of ModelOps the way that we're defining them internally at GitLab. So there's three areas that our ModelOps section is focused on today. We've got data ops, which is everything related to ELT of data, extracting, loading, transforming data. We want to make it really easy for you to connect data sources to GitLab pipelines so that you can do something interesting with it. You'll see why this is important when we get to our demo here in a bit. And then we've got MLOps, which is truly all about productionizing data workloads. So now that you've got data connected to your pipeline, you want to do something interesting with it. You want to run experiments, you want to train a model, you want to test models, you want to deploy those models. All the foundations of building, training, and deploying a model. This is a pretty industry standard term. You'll hear ModelOps and MLOps sort of interchangeably depending on the customer. A lot of it just comes down to data scientists building and exploring data sets. And then finally, we've got applied ML. This is really about taking machine learning and applying it to a production application. For us internally at GitLab, we're now starting to introduce machine learning to GitLab features to make them smarter, more automated. Our first feature in this area will be suggested reviewers, which we'll talk a little bit about here in a bit. So this is kind of the foundation of ModelOps. You'll hear these terms particularly internally, as this is how we're defining our approach to machine learning, but a lot of these terms are industry standards, so you may hear customers talk about them as well. So I want to talk a little bit about some of the common pitfalls when you've got data scientists working within a software development environment. And some of these things will sound very familiar to the early days of DevOps. So you've got a lot of teams that have data scientists that kind of live off to the side. They work in silos that have special teams. A lot of times data scientists are not software engineers. They are not DevOps engineers. And so they're not using tools like GitLab. In fact, in many cases, they're not using standard DevOps practices. They're using one-off machine learning tools that are still relatively new. If you think about it in the realm of software development, data science is still in its early days. We're still kind of cutting our teeth on the tools, the techniques, the companies, the open source projects within the machine learning space. So it's all still very early. And what this kind of leads to is this handoff friction and finger pointing where there's a lot of uncertainty about how data science works. For one, it's not like a traditional software development lifecycle. It's a lot more iterative. It looks a lot like the agile process. However, it is very experimental and very different to the way that traditional software development works. Very few data science teams think about security, which is a little problematic these days, especially considering how much data we're pushing through models and what we're using models to do. So that's kind of some of the common pitfalls. And if you have heard our sales strategy with GitLab, a lot of this comes down to this complexity. The current state of machine learning looks very similar to DevOps 10 years ago. Lots of point solutions, lots of individual companies and open source projects that you have to glue together. They all have different data models. They have a lot of complexity with them. There's a lot of lack of transparency between all of these tools because they don't talk to each other. And so we're trying to do for machine learning what we've done for the DevOps space is bring all of these tools together, help glue them together, and make it easier to share your data across your software projects and actually do something productive with that data. So a common thing that we hear when we're talking with data scientists sounds very similar to those early DevOps problems of, well, it worked on my machine. And this is what we see with data scientists is because they're not software engineers, because they're not DevOps engineers, they're downloading whatever open source package, installing whatever Python packages onto their local machines. They're downloading whatever data they can get their hands on. And it's very hard to replicate data science at scale, especially when you start introducing more team members. In many cases, companies start with 1 or 2 data scientists where this isn't a huge problem. But the moment that data scientists start producing value, creating models that do interesting things that they want to integrate into their applications, you end up in this problem of DevOps of, well, how do I replicate those results? How do I integrate that into my software development lifecycle? How do I create a repeatable cycle so that my software engineers can repeat what the data scientists have been able to produce on their machines. So it looks very similar to those early days of DevOps. And in fact, that is really all we're trying to do with our ModelOps stage is bring the foundations and the best practices of DevOps to all of these individual components to really make things repeatable, to make them scalable, and to introduce continuous development and integration to data scientists. We want to take data science that right now is off on an island over there, and we want to bring those data scientists into GitLab so that when data scientists are ready to productionize models, they're already source controlled. They're already running in repeatable environments. They're already running in GitLab so that it's easier to integrate into those production applications that are built with GitLab. The way that I think about this today is that ModelOps for us is really a land and expand within our existing customers. We want to bring new usage seats online with those data scientists who aren't using GitLab today, but their organizations are. So that's really how we're approaching this. And when you think about the way that we're approaching data science, really what we're trying to do is create these very simple handoffs between these different stages. So when you're thinking about data ops, it's really about getting the data, cleaning it, processing it, connecting it to a GitLab pipeline. We want to connect data to code. And so we've got source code today, CI/CD, our bread and butter, things that we've done for a decade now. We want to bring that to data scientists so that they can introduce those concepts to their data science development lifecycle. It's very common to talk to data science teams and they're not even using Git. They're not using any type of CI/CD. And so when we try to talk to them about coming onto GitLab, it's kind of going back to the original, here's introducing Git, CI/CD, GitLab, and getting them on board to understand how to use those technologies. And then when you think about handing off models to production, this is when we take data science and we go back to DevOps. where we're introducing those repeatable software builds and ability to deploy to production. So let's take a look at some of the differences between these personas and the way that they work every single day. So when you've got data ops folks, let me just build this out. You've got a lot of data engineers, data analysts. Generally, they'll have data in their name. These may be more similar to software developers, as it takes a lot of code to process data, to collect it, to clean it, to do something with it. I've never talked with a company whose data was not messy. It was not all over the place. And so there's a lot of code that gets written to try to collect and clean up that mess of data. This is where you'll have things like ELT, which is extract, load, and transform. There are many platforms like Snowflake, Google BigQuery that do these types of solutions to take data that's all over the place and in many different shapes and forms and standardize it and clean it and make it easy to interact with. For MLOps, what you'll generally see is data scientists or machine learning engineers. While they may have the title engineer or software developer in their name, they're not like traditional software developers. They're generally not going to be building production services and solutions. Instead, they're going to be very experimental. They know just enough software development skills to be dangerous. They generally try to use the simplest solution to produce value with those machine learning techniques. And then we've got, of course, our classic DevOps, software engineers, DevOps engineers. They're really focused on velocity, repeatability, security, those traditional DevOps principles. And so when we take a look at these users and build out what they're trying to accomplish, with the data ops folks, you're really trying to aggregate all of those disparate data sets. You're trying to clean them and shape them to make them available to the business in a way that's not complex, that doesn't have a lot of cases that you have to handle. If you've ever interacted with business data, a lot of times you end up with crazy SQL queries that have to take into account that one special case, have to merge lots of tables together. That's really what data ops tries to fix, is to make all of that simpler so that it's easy and straightforward to get business answers out of data from companies. And then for MLOps, really it's about starting to explore those data sets, to find opportunities to understand business problems that could be solved with machine learning use cases. They're building and training machine learning models to answer some of those business cases and to create value for the organization. Ultimately, data scientists want to help produce value from this data and make it useful to an organization. And then with DevOps folks, these are the traditional things that we're familiar with already: building and testing code, writing code, repeatable CI/CD, deploying those things to production, doing that in a really scalable, repeatable method. So what are some of the tools that these folks use? For data ops, we've got ELT platforms, like I've mentioned, BigQuery, Snowflake, Singer, in some cases Meltano, which is a company that was started at GitLab and was spun out. You've got a lot of data pipelines and data warehouses, lots of data all over the place, basically. We're seeing a shift now where organizations are starting to put a lot of their data into the cloud. So tools like Snowflake, Google BigQuery, AWS, a lot of those companies are moving data into the cloud to make it easier to do something with that data. This is a lot of just SQL, honestly. We have actually a data science team here at GitLab and a data team. If you Google data team GitLab, you'll find all of this stuff that our own data team does to try to make sense of all of the data that we produce here at GitLab so that we can make business insights into it. We're just now starting to get to where we're applying machine learning to some of that data to really create interesting value from it. For MLOps folks, you're looking at technologies like Python notebooks, which are basically interactive environments that are generally written in Python, where you can explore data in a really fast and iterative way. and in a very display focused manner so that you can see the data that you're interacting with code. We're going to look at a Python notebook here shortly. They're using open source ML frameworks. There are tons of open source technologies that are used by data scientists. I would say most of the data science realm is open source. And so there's a lot of OSS community. There's a lot of just downloading things, throwing them together in an environment and try to get them to work. You've now started to see the rise of data science platforms. In many cases, these are companies that are building around open source libraries like MLflow. If you think about, or if you've heard of a company called Databricks, they've built MLflow to build a company around it, very similar to the way that GitLab has. We're now seeing these data science platforms that are very point solution based. So they do particular aspects of data science really well, but they don't integrate with a lot of tools. And so you end up having to glue a lot of these pieces together. DevOps folks, IDEs, CI/CD platforms, source code management platforms. And so what we want to do is we want to take all of these unique individuals, we want to bring them all together within GitLab so that the handoffs of what they're developing is much more straightforward. We want to help them collaborate with each other. We want to help them interact with each other's code in repeatable and scalable processes. So this kind of leads me now to some of the product features that we're developing. I want to make it really clear that we're still very early in this space. We're just now spinning up our teams around these different product areas. We have introduced a couple of features, some of which I'm going to demo today, which include GPU support for GitLab Runner, which is a way to do specialized computing with our existing GitLab Runner capabilities. We've introduced better support for Python notebooks, which includes cleaning them up and allowing them to be run within merge requests so that you can comment and do standard merge requests with. We're now rendering those more beautifully so that if you've got embedded images in them, they all show within GitLab. A lot of what we've been focused on thus far is sort of what I call just quality of life improvements. These were things that didn't work on GitLab for machine learning use cases that we just had to fix so that they worked to get those data scientists to start using GitLab. So I do want to talk a little bit about what this looks like in practice, and then we'll jump over to my demo. So I want to focus particularly on MLOps because this is that sort of joint piece where you take a lot of the data science and you move it into the production workloads. You've seen our infinity loop with all of our different stages. MLOps kind of has its own version of that ML loop, which introduces this sort of design phase. When you think about it, machine learning is a lot about getting access to data, exploring it, trying different things. You go in sort of an iteration loop just with exploration before you then actually start building and training models. Sometimes those models don't do what you think they should or don't produce any value, and so you go back to the drawing board. So there's this heavy design component around machine learning that really is about what data do I have, and exploring how you can use that to find value. In the middle, you've got the model development piece, which is really about data engineering, which is what I was talking about, where you're exploring that data to find new opportunities in it. You're running various data checks. This is where a lot of Python notebooks come in, where you're just kind of exploring what the data looks like and how it works, where you might be able to produce value, and even just what data do I have access to. This is where you start building those models and finding those insights within the data. And then once you've got a model that is producing value, then we're going to hand it over to engineering and help them get it integrated into a software product. That's where you then kind of start all over again. You take the model and you try to reverse it into the software development ecosystem, where in many cases, Python is going to be the language of choice for machine learning. And so what happens if you've got a Ruby on Rails application? How do you take Python code and put it into Ruby on Rails? That's where the operations piece of data science comes in. And that's a very messy process because the software engineers have to replicate what the data scientists are doing in the language and software stack that's being used for that production application and get it all working again. So that's where repeatability really becomes a problem. And then setting up how that application triggers the model, how it does inference, how it integrates into the development lifecycle. So let's take now this sort of unique MLOps development process and lay it on top of our infinity loop. And so the things you see highlighted today are some of the things that we're going to look at in my demo project. Basically, we're trying to take that experimental cycle and bring it into GitLab in our sort of infinity loop here. One thing you'll notice is that all the features that I have indicated on our graph today span across the entire GitLab lifecycle and software development lifecycle. There's something very unique about ModelOps for us is that rather than organizing in our traditional sort of stage and groups that are very uniquely focused, ModelOps is horizontal. We sit across all of GitLab. As we're introducing GitLab to these machine learning features, we're going to change various aspects of the platform across the platform to make it work for these data science use cases. So this is just the beginning. There's lots of other features that we're going to be adding here, but this is what we're going to focus on looking at practically today. And with that, I'm going to pivot over to a little demo project. I just want to caveat, I'm not a software developer, so you will see things here that are probably not suitable for production. I just wanted to get something working to give you an illustration of how you can use GitLab features today in a machine learning use case. Hopefully this is big enough for everyone. If I need to make it bigger, just let me know. So I've got a software project here today. This is actually public. You can use this with customers. You can fork this. You can play around with it. I want to walk you through just the foundations of some of these pieces. So I actually want to start initially with a Python notebook. So this project is handwritten digit recognition. This is a common sort of hello world for machine learning scientists, where we want to take an image of a handwritten digit, and we want a machine to know what digit we wrote. This is a data set that is called minced. They have a large data set for a lot of these sort of intro problems to machine learning. I used it because it's very easy to access their data set, which is why I wanted to play around with it. If you Google digit recognition, you'll find many tutorials to replicate this yourself. So let's walk through this. I've got a Python notebook open here. I want to quickly just show you what a Python notebook is. It's actually just a JSON file that produces interesting output. We have recently added support for rendering these files, and you can now use these within merge requests. We render it in the source code view here, but you can see that this is a mix of code and exploration, where I can write code and see the immediate output of it. So I don't have to work in a software development environment just in an IDE. Instead, I can write code directly in a Python notebook and immediately see the results from it. So let me kind of walk you through just one of these notebooks and introduce you to the problem of handwritten digit recognition. So a couple things. This is how many data scientists start exploring a data set. So I first want to get access to my data set. That is something that I'm using here with Torch Vision. They have access to data sets. The Minced company that I talked about before, they have lots of different data sets. It's included with a lot of Python packages like Torch or other open source ML products. We'll look at another one here in a minute. So I'm just importing my packages here. I'm going to set some very basic parameters around what I'm trying to do in terms of loading those data sets that I was talking about earlier. One thing that's nice about using a standardized data set is that they're normally organized by training and testing data sets. I'll show you what that means here in a minute. I'm basically just loading up the data, getting it connected to Torch so that I can do something with it. And then starting to explore the data, look at the different images that are in this data set, exploring how many test samples I have and validation samples. And so you see by writing this code, you then get the immediate output of it. So I can see that I've got 30,000 training samples here. I've got 10,000 validation samples and 10,000 test samples here. I'll explain this as we continue going through. And so what I did was then said, let's just take a look at these images that are in this data set. I just want to see what they look like. So I've got a variety of these images here. As you can see, they're handwritten digits. What's nice about this data set in particular, and one of the reasons I picked it, is that these images are all the same size. They're optimized so that you can do very basic machine learning on it without having to handle weird edge cases like image sizing, image formats, and all of that. It's very straightforward. They're all very unique images that are in the same format and shape and size. And so what we want to do here basically is we've got these images that we don't know what's in them, and we want to train a model to actually be able to recognize the digit that's in it and tell it back to us. So we're going to use a very simple multi-layer perceptron model here. You don't need to know anything about data science here. In fact, I don't know much about data science. I'm not a data scientist, but this is where you can start playing around with different machine learning models here. And so we're going to take the data that we've got, and we're going to bundle all of these images into different sizes. We're going to then start running them through a machine learning project here. And so I'm going to take a couple of images, and I want to see what the current data set is. This is a completely untrained model. It's a packaged model that comes with Torch Vision. I haven't done anything to this model yet. And so when you get it, an image, this one here, it's going to predict wrongly that it's a 0. This 5 is a 6. This 8 is predicted as a 0. This 2 is predicted as a 6. This 1 is predicted as a 0. So completely wrong, not even close. Not unsurprising here. We have to teach the model how to look at these. And so basically all we did here was take a very generic machine learning model, and we just passed the data in, and we got an output. We haven't done any training here. And so this is kind of the foundation of how machine learning works is you take an input, in this case, the image of a number, we run it through the model, and we get an output, and it's prediction of what it thinks it is. In many cases, you'll hear this called inference with a machine learning model. We're inferring the values based on a data set that we're passing the model. And so when we do get to production, this is where the handoff of models comes in. Once we train this model and get it working, we should be able to hand it an image, and it should be able to tell us what's in that image. That's inference. And that's what we would build into our software application. It looks very similar to an API where I would give it an image and it would give me back a value. And then we can, build interesting applications that do something around that. That's called inference. But in this case, we haven't trained anything. So we actually need to do the training so that the model does something interesting. And so here we go doing some of the training of that model. This is where it becomes important that we've got the training and the validation data sets where we actually know the data of what that image is supposed to return so that we can tell the model about it, and the model can learn that, hey, this image of a 1 is represented as a 1, and then we can teach it 1 to 10. And so we run this through. I'm not going to go into a lot of the details of data science here. You can play around with this on your own time. Basically, we're just training this model, and by passing it bundles of images, we're effectively training the model to recognize the digits that are in those data sets. And you can see that by training it just one time, we actually get a really high 90 percentile accuracy. We can continue training it in what's called epochs, where you're basically retraining the model over and over and over again in a very short amount of time. We can get that accuracy up to 98, 99% to correctly identify these use cases. But you can see where Python notebooks make this really interesting, because I can start to see the actual data and its impact on my models in a very visual way. What happens a lot with Python notebooks is that data scientists kind of do this exploration. They train a model. There are many different types of models that can be used. And so a lot of it kind of goes back to your like middle school class where you were fitting a line on your graphing calculator, that's a lot of what machine learning is like, is you're just trying to fit a data science or a data set into a defined model and get that model optimized to return the correct values that you're expecting. And so to do this, we're doing a lot of evaluating the training data that we've got, which are just unlabeled images, and the validation data that's associated with those images to say, hey, model, you predicted a 2, it was actually a 1. So the model can learn from that. So that's what we call labeled data, where the images, we have the labels for them of what their correct values are. This is called supervised learning. If we didn't have the labels for it, it would be called unsupervised learning. Again, I'm not going to get into the specifics of machine learning, but that's how we can kind of pull all of this together. And so once we take this trained model that we've now taught how to identify images, let's go back to our original example. And we give a 1, we get predicted a 1. We get given a 5, it's predicted 5. You can see we've got a very high level of accuracy now. Now this is a model that is useful for us and that we could take to an application to actually recognize digits. A common thing that you might want to do after you've done this is maybe introduce it to the alphabet. Start doing letter recognition, get into OCR. So this is a just exploration of this data set. We've done some interesting, just see what's in the data. We've run it through a model. We've then trained that model and validated the output of it. And now we've got a model that is a high prediction, like a 98 percentile model. And so now I want to do something interesting with this. Now we've validated that we've got a model that works here. So this is kind of in that exploration step that I was talking about earlier. We're just playing with Python notebooks at this moment. So now let's go back to that software repository and take a look at how we're actually going to do something interesting with this. So the first thing I want to introduce you to is just let's take a quick look at the CI YAML file here. This is where you're going to start losing data scientists because they don't understand YAML files, they don't understand containers, and they don't understand CI/CD. And so we're introducing data scientists to the concepts of GitLab. One thing that we'll start doing in the future is creating CI templates that data scientists can use so they don't have to figure out CI YAML files. They don't have to build all of these steps together. We'll start building UIs for them to connect and create these CI YAML files. But let's take a look at this. So we've got just 2 simple stages here, setup and train. And my setup environment, all I'm doing is building a Docker container that I've got in my registry here. You'll notice that I'm creating this on a schedule. I'll show you why that's important here in a second. Once we've got our environment stood up, then I want to use that CI image that we've published to the registry, and I want to run a simple Python file on it. That's all this project does. Very straightforward. And in fact, all we really care about is this train section. The funny part, when I was putting this together, the hardest part is just getting an environment to build your models and work in where you can just interact with them. I recently have a new M1 chip on Apple. It took me hours to get a Python environment stood up on my machine that I could actually run a Python notebook on. Whereas with GitLab CI, I had a very simple Docker environment stood up almost instantly. So it's one of those where the concepts that we have within GitLab can really enable us to help data scientists scale very quickly. So let's take a look at that Docker container real fast. So I've got a Docker file here. It's based on the TensorFlow image. If you're thinking, wait a second, you were using Torch in your Python notebook, why are we using TensorFlow? Great point. That's exactly kind of this exploration of data science. I'm comfortable from an exploratory standpoint with Torch. It's what I was originally trained with. So I played around with Torch first. And then when I started building my software development lifecycle, I wanted to switch to TensorFlow. And so I wanted to convert what I did in that other library to this more common and well-known library to make it easier for folks to use. I'm going to install some custom requirements here. Let's take a look at those real fast. In my requirements file, I've got a couple of Python packages, which are common for machine learning. TensorFlow, which is that image that I was just talking about, an open source machine learning framework, and notebooks, which is a Python notebook environment. We've got Torch again. And so you can build out this requirements file with whatever Python packages you need and pass those to my container. So Very, very simple Docker environment. Like I said, I'm probably not even doing this the right way for a production environment. This is just what I could quickly put together. But what's really cool about this is I don't care about the Docker environment at all. I just want to get to my machine learning tasks. So I don't want to have to continuously rebuild my environment all of the time. So what I did was basically create where did it go? Merge requests. I wanted to create an environment where I could start building this application. And so let's actually show you in a different way. If I go to my scheduled pipelines, I've actually got a build container job that is just going to trigger that container build. So let's go back and take a look at that. So every week, I'm going to have a scheduled pipeline run that's going to go and build my Docker container and push it to the registry. So let's go take a look at the registry real fast. We go to the container registry. Here's my registry image. You can see, in fact, last night it built. So this image is going to rebuild itself with the latest version of all of these libraries every single week. I don't have to do anything with it. I can download my Docker container here, load it into my local environment, and have a new fresh Docker image with all the things that I want in it. This is how we start getting data scientists to build repeatable environments that other software engineers and team members can start to interact with. And one thing you'll notice here, it's a pretty heavy image too. A lot of these machine learning libraries include lots of default data sets. They include lots of different types of models. This is now an interesting opportunity where my DevOps software engineers can come and help me reduce the size of this and start creating this more repeatably using slimmer images, all the things that me, not as a DevOps engineer, don't know how to do. So we've already created an environment where anybody can contribute to my Docker container and help make this environment repeatable, scalable, more usable. So I've got this environment that I can now start to do something interesting with. So let's take a look at that Python file that I mentioned that all of this runs. So what you're going to see here is very similar to what I did in that Python notebook, just re-implemented with the new model choice that I used here. In this case, I'm using a library called Keras. I like it because it's very straightforward. If you look at the amount of code that's here compared to my Python notebook, it's a lot less. And this is kind of the beauty of the experimental aspect of machine learning, is that we can use Python notebooks to be very verbose and experimental to see what different parameters, what different models do, and then pass that into my sort of production model here and keep it very similar. So you'll see very similar things here. I'm taking that minced data set, I'm loading it, I'm taking a look at it, I'm creating and shaping that model, loading in the training and test samples, creating the batch size that I want to use, and then training my model here. We'll take a look at the output of one of these jobs here in just a second, and then printing out a couple of just data pieces. But one thing that I want to highlight is this last piece, which is this model save. Once we've trained that model, I then want to take that model and export it. There are lots of different file formats that get used for models. In this case, I'm using an H5 file, which is really just kind of like a JSON file that just takes the trained model, its parameters, and packages it together so that you could load this model into your environment very easily. And so what you'll see normally with these types of models is that you want to export your model and then host it somewhere so that other people can find that model and ingest it. If you think about retraining a model, let's say we wanted to train it on digits or on letters, I would then go and retrain this model on letter sets, and I would have a new model that supported letters. I would then want to pass that model to my engineering team to load into the production application so they could start recognizing digits. The way to do that is to export the model so that they can import it into their environment. And so what becomes nice is that this model can actually cross languages. I'm using a Python library here, but there are Ruby on Rails. There are other language connectors that can read these models and put them into the native language that an application may be developed on. So this is kind of the way that we hand models off to production that can be used in a unique way. So let's take a look at one of these jobs real fast. Let's go into one of my pipelines. I'm going to just choose one randomly here. Let's go into this one. So we've got that setup job that I was talking about earlier. Let's go up to the top here. Starting with Docker, we're pulling in all of the different pieces. We're loading that TensorFlow image, compiling it, pulling in all of the packages that were defined in my requirements file. Lots of stuff here. Like I said, these packages are big and heavy and have lots of stuff in them. And then pushing that to the registry. So there's our Docker image. That works. Cool. Glad to see that. Now let's look at this training piece. So we've got our Docker image spinning up. It's pulling that Docker image from the registry. It's initializing, blah, blah, blah. So we've got the downloading the data set. So there's me loading in all my data. In this case, we're failing to load CUDA. CUDA is a GPU runner. I'm not using a GPU runner at this point, so that's going to fail. This library luckily handles that pretty gracefully. And so we then start to run that Python file that I was talking about earlier. So we've got some of the printed data sets that I was talking about. In this particular library, it comes with 60,000 training sets and 10,000 test samples. And then we're going to start running that through our TensorFlow model. Here is me looking at that model, what it's doing. Again, I'm not going to go through all of this. In fact, I probably can't even explain what a lot of this does. But you can see there's some parameters in here. And then I train the model and get a test accuracy. And then I save that model as a M5 file. Cool. That's it. That's all this project does. But I haven't done anything at this point. I haven't saved that model anywhere. It's in my container, but I haven't exported it in a way that I can actually get access to in CI. So let's now start to expose some of these files to this project. So I've got a couple of just sample merge requests here that do various things. And so I want to go into this model export. So let's take a look at what I'm doing in this file. All I'm doing is creating an artifact that includes this trained model. That's all I'm doing here. And so let's take a look at what this looks like. We've got our original job here. We've got our training job. We saw that earlier. In this case, I expanded the number of epochs so that I could actually train it to get to something interesting. You can see that as we go through here, it's getting better in its accuracy as we go, but it's definitely not as accurate as the other one that we were using before. Totally fine, whatever. But we've got that model here. We are then uploading that artifact to the artifact of this job. And in fact, there it is. I can browse it. And now I've got this artifact that can be produced repeatably. Very cool, very interesting. You can see my model here is about 2 megabytes. As we train it more, it'll get bigger. Now we're starting to get somewhere where I've got a model that's repeatably generated with CI. Again, this isn't a production repo, but you can imagine how we now have an environment where every week I've got a new fresh Docker container that gets spun up, that's running my model. And now I want to actually start to do something interesting with this model and make it usable for people. So let's go back to my merge request and we'll move on to the next one. So now I want to actually package that model together in a way that could be pulled from different application or from different repositories. So I'm going to take that artifact that I had before. So there's my artifact and my trained model. And now I actually want to publish it to the package repository. So I'm going to create this as a manual job so that I can decide when I push this model version. I'm going to create a variable so that I can define this version. And then all I'm going to do is take that file. I'm going to push it to the package registry. Okay, so let's go actually take a look at our package registry. Where is it? There we go. And there it is. There's my model, my first version of this generic package. I'm using a generic package here because it lets me put any file that I want in it. In the future, we'll support proper machine learning models here. But for now, there's my file. In fact, I can download it. If I look at the file itself, this now allows me to interact with this package from other software projects. I can hit the GitLab package registry, can pull this model into other software packages. That's a big repeatability win here. Now I can repeatably publish this model and make it available to other software packages. So let's go back to this whole thing. Let me show you what one of these Python or one of these pipelines looks like. Come on. Did I switch internets? There we go. Let's see, which one do I want to look at? Oh, wait, I'm sorry. I want to look at the merge request. So that model, so let's look at a pipeline here. Yeah, let's look at this one. So I've got this published job here. It runs my model, and all it's doing here is pushing that image to the repository or to the package registry. Very simple. This took me a while to figure out how to do. This is the piece that data scientists aren't familiar with, of how to start productionizing a lot of their data science workload. And so this is where we want to really help make these things more understandable, create CI templates to make this very usable. Now, I want to show you one other last thing that as we start doing this, we can then layer on top other machine learning or other GitLab features. Come on, merge requests. So now I actually want to take everything we've done thus far, and I just want to add security scanning to it. This is something that we offer out of the box with GitLab. It's very simple to enable. I'm going to add all of my security scanning capabilities. So I'm going to now enable our secure. Let's take a look at what this actually looks like in practice. So all I'm doing now is looking at all of the security vulnerabilities that I have. And now I've got a very useful list of things of how I can improve the security of my software project. In my Docker file, I'm not properly setting users, and so I'm running these things as root. I'm not using specific tagged versions of libraries, so I'm just trusting that the latest version is going to be secure and is going to work and not break things. These are really obvious DevOps things now that me, as someone who is not a DevOps engineer, can now very quickly understand and layer into my software development lifecycle. I can check this for leaked secrets. We can scan the container for security vulnerabilities. So you can see how just by doing some very basic things to start using the capabilities that we have within GitLab, we can get a lot more value and build much better machine learning models. So that's going to conclude my demo here. That's kind of an overview and an intro to how you can use various GitLab features within the machine learning context. The only last thing I'm going to leave you with is some of the things that we're working on at the moment. With our MLOps team, we are working on Python notebook enhancements to make those Python notebooks work better. We're soon to move to a model registry. So I showed you how to pass that package to the package registry. We're going to support a machine learning model package. In fact, we're going to try to create a standard around this to create a new way to share repeatably these models. And then we're going to add support for external for advanced computing. So enabling GPU runners, make them very easy to use. You saw where my GPU had failed in my test example because I'm not using a runner that has a GPU enabled on it. We support this today for self-hosted runners, but that requires you to spin up a GitLab runner, connect it to GitLab. It puts all of the work on you. We'll soon offer GPU-enabled runners natively on GitLab.com. And then on the applied ML piece, this is us taking machine learning and applying it to GitLab. Our first feature is coming out in 15.4, which is suggested reviewers, which is a novel machine learning algorithm that learns from your source code and your commit history and suggests reviewers for your merge requests based on the changes that are in them. So if we think about what we were doing with that model before, rather than images of digits and labels, we're passing it the contribution graph, and we're getting the model to tell us back who should be a recommended reviewer. So like I said, that will be releasing in 15.4. We'll then move to suggested labels to have merge requests and issues automatically label themselves. And then we'll move to intelligent code security, where we'll actually have a machine learning model suggesting how to fix security vulnerabilities and creating merge requests for those fixes. So those are just some of the things that the ModelOps team is working on. So we're kind of working in a dual track here, where we want to make it easier to run models and use them with GitLab features. And then we want to apply machine learning to GitLab itself to make it smarter and more intelligent. So that is an overview of kind of the intro to data science, a quick view of how you can use existing GitLab features with machine learning capabilities. I encourage you, go play around with this repository. If you Google intro to machine learning courses or just tutorials, you can leverage this framework to explore some data science models yourself with either TensorFlow or Torch. So hopefully this is useful and interesting to you. Hopefully this gives you a little insight into how data scientists are starting to use GitLab, and there is much, much more to come from our ModelOps team moving forward. I realize I have not left much time for questions, but if you've got questions, put them in the doc and I can respond async to them.
Yeah, we have actually a great list of questions in the doc. If we have a couple of minutes, we can probably take maybe one or two live, and then absolutely the rest will probably have to be async. Samir, looks like you have the first one. Maybe we'll start with that and see how long we go.
Yes, thank you. Thank you, Taylor, for the presentation. This was excellent and very, very insightful. The question I had was with regards to the Jupyter notebooks. You showed it being rendered in GitLab. Are we planning for it to be editable within GitLab using the GitLab editor? Is that a plan in the future?
Yeah, absolutely. That's what I'm vaguely calling enterprise Jupyter notebooks. Basically, there should be a software environment behind that image that imports basically just a Python environment. We want to enable you to spin up a environment with GitLab Runner to basically press play on that notebook and then be able to edit, interact with it, replay cells, very similar to Jupyter Hub. That will be a paid Ultimate Plus feature for customers. For now, we wanted to get it just so that you could render and view them, but we definitely want to create live running notebooks.
Excellent, thank you.
I don't know if Leo's still on. Oh, there he is. Leo, looks like you have the next one.
Yes, actually, I just wanted to know, the model that you were using, does it use pixel patterns to identify the numbers from the images?
So it's not using pixel patterns from the sense that like nobody made those, but it is effectively what that model is doing. Basically, we hand it an image and we tell it this is a 1, and it reverses to figure out what that 1 is. It is behind the scenes using something that would be similar to what we think of as a pixel pattern. In fact, in that last image in that Python notebook, you can see basically what the machine sees of that image. Now, of course, like it's not actually looking at it, it's just data representations, but yeah, it's a good way to think about that.
Great. Did you have any follow-up there, Leo? Sorry.
No, I appreciate the insight. Thank you.
Wonderful, thank you. Probably just one more and then we'll take the rest async. Cherry, looks like you had the third one.
Yeah, thank you, Taylor. It's a great demo. I'm working with the customer, and I have seen it with other customers. They're differentiating their work and the pipeline for platform versus delivery. I can't even say that word today. I'm just wondering, is our applied ML is really considered from practice point of view as a delivery pipeline?
Yeah, so it's a fair way to think about that. From the standpoint of like a customer, when they turn on suggested reviewers, that's not going to be something that you're going to have to see all of the workings of these MLOps workflows. Behind the scenes, yes, we do have GitLab pipelines that are extracting data, they're transforming it, they're training a model, they're inferring them all of that's done holistically within GitLab CI. But customers won't see that. There will be a simple job that will trigger our internal pipeline, and they'll see those recommendations within their UI. But yeah, that's effectively the right way to think about it, is that it is a production machine learning pipeline. And that's what we're building with Applied ML.
Cool. So they're working on something they call that next best conversation. Really is to engage the customer and the present offers. So it's very interesting. We will get you to talk to this customer for sure. I think just lighting up all the dates, that would be great. I like your example. Yeah,
absolutely. And that's a good plug for me. If you've got customers who mention machine learning, they don't know how to get started with GitLab, or maybe they're already doing something today. If you've got those customers, I want to talk to them. I want to have them help shape our roadmap as we develop here. I'm always happy to talk through both this example and this presentation to talk through some of our roadmap with these customers. So don't hesitate to reach out.
Thank you for that. I will reach out to book the time. I pinged you a few times, but finally we have some dates that wouldn't work for you and us. We had some sessions already. I think we're at the right time to look at their pipelines. They did start implementing in GitLab, but of course has a lot of challenges.
Yep, absolutely. And I mean, as you've seen here, a lot of this talking with customers is just introducing them to GitLab features and how they can use them in a data science context. So it's a lot of DevOps one-on-one with these customers, teaching them how to use GitLab. Awesome. Well, I think we're about out of time. I will respond to the rest of these questions in this Google Doc. I really appreciate all of the questions, and hopefully you found this useful. Like I said, feel free to use this repository however you like. Do please fork it, because I will use this for my own customer demos. And that's all I've got for you.
Wonderful. Thank you all so much for your time. Thank you, Taylor. Great presentation today.
Awesome. Thanks, everyone.
Thank you all.